Chapter 14 starts on page 329 in your book. This week we're going to be discussing ratio strengths and percentage strengths. So whenever we are talking about certain medications that are expressed as a ratio strength or a percentage strength, usually we're talking about liquid medications like injectables or IV bags oftentimes are expressed in percentage strengths, but we could also be talking about things like creams or ointments as well. So we're either dealing with liquids or usually semi-solid medications. Regardless, anytime you see a ratio strength or a percentage strength, that is going to be expressing the amount of medication or the amount of active ingredient per the total volume or weight of that medication. So starting with percentage strength, anytime you see a percentage, we can always express that as an amount of medication out of a total of 100, in this case, milliliters or grams. So we're going to take a look at some examples of that really quick here. So on your lecture worksheet for this week, I wrote you some rules that we need to remember here. So the first one, anytime we see a percentage strength, we can always change a percentage into a fraction by just taking that number and putting it over 100. So let's just take a look at some percentages real quick. For example, if we had 25%, we see the percent sign. So if I want to change this to a fraction, all I have to do is take this number and put it over 100. So 25% is 25 out of 100. Let's do 136%. Just take this number, put it over 100. Now in this case, we could reduce, and you could really reduce this one here as well. I just want you to get in the habit of anytime you see a percentage, take that number, put it over 100. Even if it's a decimal, 0.125%. Change that to a fraction, 0.125 over 100, okay? Now, when we're talking about percentage strengths of medications, the X is always going to be the amount of active ingredient, and the 100 is always going to be the total volume or weight that we're looking at, okay? Now, some things that we have to consider. Depending on the type of drug that we're looking at, we can have one of these three options here. So, for example, if we are looking at an IV solution, usually the active ingredient that has been dissolved in that solution was in a powder, and then the total volume that it's being put in is a liquid. So that would be an example of a weight per volume. So where the weight was actually some sort of powder put into a volume, which is a liquid, okay? So in this case, anytime we're dealing with percentage strength or ratio strength, the unit of weight that we're going to be using is always grams. The unit of volume is always milliliters. So this is a rule that you have to remember. Weight is grams, volume is milliliters. So for this case, if we had a weight per volume, that would be grams per milliliter. Now, if we were looking at a drug like a cream or an ointment, where the active ingredient was measured out in a powder and it was also put into a cream, both of those types of medications we would weigh out in grams. So that would be a weight per weight or a gram per gram. Now, if we had a solution in which the active ingredient was a liquid and the solvent or the diluent was also a liquid, that would be a volume per volume or a milliliter per milliliter solution. Okay, this will make sense when we start to see some more examples, but these are the rules that you have to remember here. We're just focusing on percentage strength right now. Anytime you see a percentage, just take that number and put it over 100. And depending on the type of drug we're looking at, weight per volume, weight per weight, or volume per volume, we're always using the units of weight as grams and the unit of volume as milliliters. So let's say I have a 10% weight per volume solution, and I want to write this in a fraction. Anytime I see a percentage, you can always just take this number and put it over 100. 10 over 100. Since this says weight per volume, that means my numerator is weight, so grams. My denominator is volume, so milliliters there. That means that there are 10 grams of active ingredient in every 100 mils of total solution. So your numerator is always your active, your denominator is always your total. Okay, so when we're talking about IV solutions, a lot of times the base ingredients in those IV solutions are expressed in percentage strengths. So if you take a look at page 330 in your book, there's table 14.1 that gives some abbreviations for the common IV solutions that we'll see in the pharmacy setting. I also have listed them on this next slide here. So probably the most common one that we'll see is going to be NS, which means normal saline. So saline is just a saltwater solution. So normal saline has a concentration of 0.9% sodium chloride, which is table salt, in water. So remember, back to our percentage strength. Anytime we would want to write a percentage and a fraction, we would just take this number, 0.9, and put that over 100. Now, your IV solutions are going to be weight per volume measurements. So here we see there's 0.9 grams of sodium chloride in every 100 mils of water, or in the 100 mils of that solution. And then we have some more abbreviations that you will be responsible for studying this week. So half normal saline, which is just half of 0.9 here. So we have 0.45% sodium chloride, which means that there's 0.45 grams of sodium chloride in every 100 mils of solution. D5W. So D stands for dextrose, which is a type of sugar. So D5 means there's 5% dextrose in water, which is W. So 5% means there would be 5 grams of dextrose in every 100 mils of water. And you can really see D with any number here gives you a percentage. W just means that percentage of dextrose in water. Like this one is D10W, 10% dextrose in water. You can also have solutions that are combinations of dextrose and saline. So like this one, D5NS, 5% dextrose in normal saline, which we said was 0.9% sodium chloride. So 5% dextrose in 0.9% sodium chloride. So that means that there's 5 grams of dextrose in every 100 mils of water, and also 0.9 grams of normal saline in every 100 mils of water. And then this last one here, Ringer's lactate or lactated ringers. You'll hear it both ways. It's just a combination of dextrose, sodium chloride, lactate, potassium chloride, and calcium chloride as well. So once again, these are just common base IV solutions in which we would add in active ingredients to prepare those medications. And like I said, these are also in your book on page 330, this table 14.1. So when we start percentage strength calculations, the easiest thing to do first is to convert your percent into a fraction. So here we have a 10% solution, which we know weight per volume means we're going to be using grams per mil. So we have 10 grams of active ingredient in 100 mils of solution. Now, the easiest way to calculate the amount that's given in a specific quantity, like in a total bag, is going to be to use ratio and proportion. So this first example here, a physician orders 500 mils of a 5% dextrose in water solution, or D5W, for a patient. What is the weight of dextrose in the bag? Okay, so let's start our calculation here. We see a percentage strength. We see 5%. Anytime we see that, we can write that as 5 over 100. We know that this is an IV solution, so it's going to be a weight per volume. So we have 5 grams of dextrose in every 100 mils of water. Excuse me, and they're asking what is the weight in the bag? Well, we know that the bag, they're ordering 500 mils. So we're going to use ratio and proportion. When you set two fractions equal to each other, make sure that your units are equal to each other. We know that the bag has 500 mils, so we're going to be solving for X, which will tell us how many grams of dextrose are in the bag. So we're going to cross multiply and then divide. So 500 times 5 gives us 2,500, and then we would divide that by 100, which would give us 25 grams of dextrose. So let's take a look at number 1, very similar. How many grams of dextrose are in a 1,000 ml bag of D10W? Well, D10W, we have to know what that means. There's 10% dextrose in water. So we know that we're looking at a 10% solution. Take your percentage, anytime you see a percentage, automatically change that into a fraction. We know that there's 10 grams of dextrose in 100 mils of total solution. Now it says, how many grams of dextrose are in 1,000 mils? Well, the easiest way to do this is with ratio and proportion. I know mils has to stay on bottom here, so 1,000 mils. I'm solving for how many grams of dextrose, which would be on top. Cross multiply here, 10 times 1,000 would be 10,000 equals 100x. We're going to divide by 100, and that leaves me with 100 grams of dextrose. All right, number 2. How many milligrams of sodium chloride are in 500 mils of D5NS? Well, first, let's take a look at what this means. 5% dextrose in normal saline. So look at your chart. Normal saline is 0.9%. sodium chloride. Now, go back to your question. How many milligrams of sodium chloride are in 500 mils of D5NS? So they're not asking us anything about dextrose, so we really don't need to worry about that. We're just worried about the sodium chloride. We know that there's 0.9% sodium chloride. We see a percentage, automatically change that into a fraction. 0.9 grams of sodium chloride in every 100 mils of total solution. And we're looking for how many milligrams are in 500 mils. So we're going to set that equal to 500. Now remember your X here, that's going to give us our answer in grams. The question is asking for milligrams. So we're going to have to convert after we solve here. So we're going to take 0.9 times 500, which gives us 450. Set that equal to 100x. And then we divide by 100 to get x by itself. So 450 divided by 100 gives us 4.5 grams, which we need milligrams. So to go from grams to milligrams, we're going to multiply by 1,000 or move our decimal 3 places to the right. So this equals 4,500 milligrams of sodium chloride. All right, let's take a look at number 3. A physician orders 1.5 liters of 3.5% trabasol, which is amino acids, to be used in a total parenteral nutrition bag. How many grams of amino acids will be provided? Okay, so first thing, you see your percentage strength. Set that up in a fraction. 3.5 grams of amino acids in every 100 mils of total solution. It says how many grams of amino acids will be provided from the bag. So the bag is 1.5 liters. Now keep in mind our volume that we have here is in milliliters. So we're going to have to convert. So 1.5 liters going to milliliters. We're going to multiply by 1,000 or move our decimal 3 places to the right. So 1.5 liters is 1,500 mils. So now we can set that equal to our total volume here and solve for x. So go ahead and solve for x on your own. And then I'd like you to write your answer down below. Okay, number 4 says to do number 2 on page 332. So here is the IV solution, and it says, what is the weight in grams of dextrose in the IV? So let's take a look at our IV bag. So this is an example of a label of an IV solution here. So we see a 5% dextrose injection, and it is 1,000 mils. Now, 5%. Immediately, let's change that into a fraction. So 5% would be 5 grams of dextrose in 100 mils of total solution. And it says, what's the weight in grams of dextrose in the IV? So in the total bag, well, our total bag is 1,000 milliliters. So we're then going to set that equal to our total volume. which is 1,000 mils. And then we can solve. So go ahead and solve for x on your own, and then you can circle your answer. Okay, number 4 on page 334 is next. So number 4, what is the weight of sodium chloride in grams in the fluids shown below? So here we have 0.45% sodium chloride, and we have a total of 500 ml bag here. So I'd like you to solve for this one on your own. If you don't have enough room here, which you should, but if not, you can do that on the back of the worksheet or just on a piece of scratch paper. Just give me directions on where your answer for that one is. Okay, number 6 says, interpret the following medication. We have a 20% neomycin solution. That is a weight per volume. So on your interpretation, all I want you to do is basically write out what we know about this percentage. So we know that a 20% solution, that's weight per volume, means that there are 20 grams of active ingredient, which is my neomycin, in every 100 mils of solution. So we're basically just writing this out in words rather than in a fraction like we would, 20 grams over 100 mils. So I just want you to write that out in words here. And I want you to do that on practice problems B when it says interpret the strengths of the medications shown. On this line here, so like number 1, 7.5% magnesium sulfate solution, it's a weight per volume. That would mean that there's 7.5 grams of magnesium sulfate in 100 mils of solution. So that's how I want you to do the interpretations for practice problems B. Okay, so back to this question here. It says, how many grams of neomycin are in 300 mils of total solution? Well, we already know our fraction is 20 grams of neomycin in every 100 mils of total solution. And we're going to set that equal to our 300 mils of total solution. And then solve for x. You should be able to solve for that one on your own there. So just make sure you write out your answer and circle that. And then we can move on to number 7. All right, so this one's a little bit more tricky here. How many milligrams of neomycin are in 6 ounces of a 25% solution? So start with what we know, our 25% solution. We know that that means there's 25 grams of neomycin in every 100 mils of total solution. Now we're looking for 6 ounces total of solution. So we're going to have to convert our ounces into milliliters. You should know that 1 ounce is 30 mils. So 6 ounces, we would take 6 times 30. 6 ounces would give us 180 mils. Now we can plug that into our equation here. So we have 180 mils here. Now keep in mind our x is going to be in grams. So the question is looking for milligrams. So what I'd like you to do, solve for x in grams and then convert that into milligrams. So 25 times 180 gives us 4,500. And we're going to set that equal to 100x. So x is 45 grams. But remember, we need to go to milligrams. So take this times 1,000, or just move your decimal 3 places to the right. So that equals 45,000 milligrams. Okay, so now A, what is the strength in milligrams per milliliter? Well, we just solved for the milligrams, right? We know that there's 45,000 milligrams in 180 mils. So we know that that is the case because we just solved for that, right? So they're asking for the strength in milligrams per mil, which is what we have here, but we need to make sure that we reduce this to milligrams per 1 mil. So you can simply just divide this, or you can set it equal to x over 1 mil. Essentially, we're still just taking 45,000 divided by 180. So when you type that into your calculator, you get x equals 250 milligrams. So the strength in milligrams per mil would be 250 milligrams per that 1 milliliter there. Okay, now B. How much neomycin powder is needed to make 60 mils of a 20% neomycin solution? So just think about this question, what they're asking. How much neomycin powder? How much active ingredient? Powder, that's grams, that's a unit of weight. We're making the total volume of 60 mils of a 20% solution. Well, I see that percentage strength. Always start with your percentage, write that as x over 100. So 20 grams of neomycin in every 100 mils of solution. Well, we're looking for how much neomycin is needed to make 60 mils of solution. So even though this one's worded a little bit differently, same exact type of problem we've been doing. You just kind of have to read the question to understand what it's asking for. So this one, go ahead and solve for x, and then just make sure that you circle your answer on there as well. Okay, number 8. A physician orders 2.5 liters of 15% neomycin solution. The available neomycin is 0.5 gram tablets. How many grams of neomycin are needed to fill the order? Well, all they're asking right now is for grams of neomycin. They're not asking us about tablets right now, so we really can ignore that. What we need to know is our strength. We have a 15% solution. So start with that. We know that that means that there's 15 grams of neomycin in every 100 mils of solution. And we're looking for how many grams of neomycin are needed to fill the order. Well, it says the order is 2.5 liters. So we're going to set that equal to our volume, but we're going to need to convert this liters into milliliters. So 2.5 liters, we're going to take that times 1,000, or move our decimal to the right 3 places, which would be 2,500 milliliters. then we can solve for x. So 2,500 times 15, and then we're going to take that divided by 100. So x gives us 375 grams of neomycin. A lot. We need a lot of neomycin here. So now the available neomycin is 0.5 gram tablets. How many tablets would we need to fill this order? Well, we need 375 grams, and each tablet is only 0.5 of a gram. So if we want, we can use ratio and proportion. Start with what we know. We have 0.5 grams in each tablet. So one tablet is 0.5 grams. Set that equal to what we're looking for. How many tablets? Well, our x would go on top. We need 375 grams of neomycin. So 375 times 1 is just 375. We're going to divide that by 0.5, which would give us 750 tablets. So if you were making that order, and I would not take the time to crush up 750 tablets, I'd probably just see if there's a higher strength tablet available to make that order. But just for this problem's purposes, we would need 750 tablets. Okay, number 9. How many mils of D25W should be administered to a hypoglycemic patient to provide 150 milligrams of dextrose? So this one's a little bit different. They're asking us for the volume now, and they're giving us the amount of active ingredient. But regardless, we always start with our percentage strength. So D25W means that we have a 25% dextrose solution. So 25% dextrose in water. What that means, 25%, we always can write a percent over 100. 25 grams of dextrose in every 100 mils of solution. Now this time we're looking for how many mils. So my x is going to go on the bottom, and we're needing to provide 150 milligrams of dextrose. Well, I can see that this is in grams, this is in milligrams. So I'm going to need to convert one of these. I think it'd be easiest since I already wrote this down in grams. Let's convert this into grams as well. So when you're going from milligrams to grams, you're going to the left 3 places, or you're dividing by 1,000. So 1, 2, 3, that would give us 0.15 grams of dextrose here. And with that set up, you should be able to now solve for x. All right, so the last percentage strength example here. How many mils of a 30% neomycin solution can be made from 225 grams of neomycin powder? So very similar to the last one. So we have a 30% solution, 30 grams of neomycin in every 100 mils of solution. We're looking for how many mils. So our x will go on the bottom. And we know that we have 225 grams of powder. So when we solve this here, 225 times 100, and then we're going to take that divided by 30. So that gives us 750 milliliters. Okay, so now says, how would the formulation instructions read for this preparation? Okay, so what we're going to do, I want you to think about how we're going to make this. We have a powder. We have 225 grams of neomycin powder. And then we also have the total volume, right? This says how many mils of the solution can be made. So this is our final volume. So final. So I want you to think about this visually. So let's say we add this powder. These are definitely not to scale, but we add all of our powder into our bottle. So we have 225 grams of powder. Now we know that we're going to add enough diluent, whatever that may be, or our solvent. We'll just say that this is water. We know that we're going to need to add enough solvent to get us up to a final volume of 750 mils. Okay, that does not mean we're adding 750 mils of this solution to this bottle, because when this powder dissolves, it's going to take up space of its own. Now, right now, we're only measuring that in weight, which is grams. But we could not say how much volume, how much space in milliliters this would take up. We just cannot calculate that. So when it comes to the solvent, what we say is add enough solvent to get up to the total volume of 750. And how we write that is by saying QS to 750 mils with solvent. So we would start out, so it's asking for the formulation instructions. So we would start out with 225 grams of neomycin powder. And then we would QS, which means quantity sufficient, or add enough to get up to the 750 mils with our solvent. Okay, so remember, that's our final volume. We really cannot calculate how much solvent we would need because this powder is going to take up space of its own. Okay, so back to the slides. There's another example for percentage strength. If you'd like to go through that on your own, just really make sure you're reading your problems carefully, especially when we're looking at these combination solutions. Like this first question says, what's the weight of dextrose in the bag? So if you're looking at dextrose, you really only need to worry about the 10%. You don't need to worry about the sodium chloride. Same thing here. What's the weight of sodium chloride? It's just asking you about the normal saline, which is 0.9% sodium chloride. So you wouldn't have to worry about the dextrose in that case. This next slide is also very important to remember. So the amount of active ingredient in a product, we're always going to assume that we're working with grams unless they tell us otherwise. Same with the quantity. We're always going to assume that the quantity is mils unless they tell us otherwise. So back on the front page of your worksheet here, we're always going to assume the weight per volume unless they tell us that we're working with a weight per weight or a volume per volume medication. So that's why all of these examples that I've gone through so far, we have used weight per volume. But keep in mind, in your problems, in your practice problems, you're going to see weight per weight and volume per volume calculations as well. We're going to talk about ratio strength in the next lecture. So that's in the next video. I will cover that here in a little bit. The rest of these slides kind of go through some shortcut equations. I don't recommend trying to memorize these equations. I would really like you to be able to solve these questions using ratio and proportion like we have. But if you feel like you're more of an equation person, I didn't take these slides out. But I'm not going to go through all of these because I really want you to understand that ratio and proportion concept. So these are all examples of that. And then this last slide here on percentage strength, this is discussing what I was just talking about on that last example of quantity sufficient. So when you're making a specific quantity of a weight per volume solution, there's no way to know exactly how much solvent we need, and that's because that powder dissolves and takes up space of its own. So the solvent, especially in the directions like this one here on number 10, we're always going to say QS or add enough to get up to the total volume. Okay, and then you'll notice after number 10 on your worksheet, I say work on practice A and B. So this would be a great time. We've just completed the percentage strength portion of this chapter. Go ahead and work through your practice problems A and B to make sure that you have these concepts down now before you move on to the ratio strength video.